Narwhals live year-round in the high Arctic, where sea ice covers the surface most of the year. They survive by using leads, cracks, and breathing holes that can shift overnight. Narwhals are medium-sized toothed whales closely related to belugas, with thick bodies built for steady swimming. Their lack of a dorsal fin helps them move under ice without scraping. Their skin shifts from dark at birth to pale gray in mottled patterns as they age. Those speckles can help break up their outline in dim, ice-filtered water. The famous tusk is an elongated canine tooth that grows through the upper lip, usually in males. It can reach several meters long and forms a natural spiral along its length. For centuries, tusks were sold as unicorn horns because their true source was hidden in remote Arctic seas. The myth lingered until scientists linked the tooth to the narwhal. Modern studies show the tusk contains dense sensory nerves connected to the whale's nervous system. That sensitivity suggests it can detect fine changes in surrounding seawater. Researchers think the tusk may sense temperature, pressure, and salinity shifts that signal currents or ice conditions. In dim water, those subtle cues can guide movement. Because females usually live without tusks, the tooth is not required for basic feeding or breathing. That points to roles like signaling, dominance, or mate choice among males. Males sometimes tusk by gently crossing or rubbing tusks, which may test strength or exchange information. These interactions look brief and ritualized, not constant fighting. Narwhals feed mainly on deep-water fish, such as Greenland halibut and Arctic cod. They also take squid and other prey far below surface light. To find food in darkness, narwhals use echolocation clicks and listen for returning echoes. Sound becomes their main way to map prey, terrain, and the ice overhead. Many feeding dives reach extreme depths, often well over 1,000 meters. A single dive can last more than 20 minutes before they surface to breathe. During deep dives, their bodies conserve oxygen by slowing heart rate and restricting blood flow to less critical tissues. The brain and heart keep priority while the body runs efficiently. Narwhals spend much of their time under ice, where breathing options are limited and unpredictable. They must remember openings and react fast when ice starts closing. Seasonal movements follow ice cycles, but narwhals do not cross entire oceans like some whales. They travel within Arctic regions, tracking reliable conditions and prey. Narwhals are social, traveling in small groups that can merge into larger gatherings during migration. Group living can improve navigation, safety, and awareness of openings. Communication includes clicks, whistles, and knocks that create a constant acoustic background. These sounds help maintain spacing and coordination when visibility is poor. Unlike many whales, narwhals rarely breach because dramatic movements waste energy. In cold water, every calorie matters after repeated deep foraging dives. A thick layer of blubber insulates them against freezing temperatures and stores energy for lean periods. That insulation can also make overheating a risk during hard exertion. Calves stay close to their mothers and learn routes, breathing tactics, and safe ice behavior over time. This learning builds a cultural map that can last generations. Narwhals mature slowly and usually produce a single calf after a long pregnancy. Slow reproduction means populations recover gradually if losses rise. Historically, dense sea ice limited access for predators and helped protect feeding grounds. When ice retreats, threats can reach places once hard to enter. Killer whales are among the most serious natural predators, especially in more open water. Narwhals may shelter in tight, complex ice where orcas maneuver less easily. Climate change is altering Arctic ice timing, thickness, and stability, disrupting familiar travel corridors. Unpredictable ice can trap whales or separate them from feeding areas. Warming can also shift prey, changing where fish and squid concentrate through the seasons. Narwhals may dive differently or travel farther to meet energy needs. Human activity is increasing in the Arctic, including shipping, tourism, and resource exploration. More vessels bring noise into habitats that were once quieter. Narwhals rely on sound, so chronic noise can mask echolocation and reduce feeding efficiency. Even small disruptions matter when survival depends on precision. Scientists study narwhals with satellite tags, acoustic recorders, and brief field seasons. Much of their life remains hidden beneath ice and darkness. Tag data reveals repeatable dive patterns and careful timing between deep foraging and surface breathing. It also shows how quickly narwhals respond to disturbance. Despite their mystique, narwhals are steady specialists rather than spectacle-driven animals. Their success comes from efficiency, patience, and tight cold water adaptation. The tusk remains a symbol of mystery, but its biology is more impressive than the legend. A sensitive tooth that reads, "Seawater is a rare tool in an extreme habitat." Indigenous Arctic communities have hunted narwhals for generations using deep knowledge of ice and whale behavior. For many communities, the narwhal is sustenance and culture. Conservation focuses on protecting habitat, managing noise, and reducing risks as the Arctic opens to traffic. Effective protection must consider ice, prey, and migration together. Narwhals survive past climate swings, but today's pace of change is unusually fast. Their future depends on ecosystem shifts and how humans manage Arctic expansion. In the end, narwhals are living specialists of ice and deep water, not myths. Understanding them means protecting the Arctic systems that make their lives possible.